Hello, everyone. Welcome to the Sound Magazine, the podcast that turns every story into a picture in your mind.
Imagine just for a moment you're looking at a sunflower, a simple, perfectly ordinary bloom. And yet you feel this deep sense of visual comfort. It just feels right.
It's balanced, it's orderly.
Exactly. Now picture something totally different. A massive hurricane seen from space. That swirling eye of cloud and water. There's awe, maybe a little fear, but you still see it, don't you? A profound order in all that chaos.
Or even just standing outside on a clear night looking up at the Milky Way. All those billions of stars, they aren't just scattered randomly. You can feel a structure there, a kind of hidden rhythm.
And that's the astonishing part. A flower, a storm, a galaxy. They all evoke that same feeling. It's not just an emotional response. It's your brain recognizing a secret universal language. A code.
Okay, so let's dig into that. This secret code, it's not some kind of, high-level physics that only a few people can understand.
Not at all. It's a fundamental language of shape and growth. It's been called sacred geometry, and it flows through one very specific, very simple mathematical rhythm.
And that's what this deep dive is all about. We're going to trace that blueprint, the one that connects the rhythm of your own heartbeat to the rotation of the stars.
So if you think of nature as the ultimate architect, what was its biggest problem to solve?
I guess. How to build something strong?
Or big?
Close. It was how to build the most efficient thing possible. How do you create something, anything, that uses the least amount of energy, takes up space perfectly, and can just keep growing forever without, falling apart?
And nature's solution was a set of instructions.
A remarkably simple set of instructions.
Yeah.
The Fibonacci sequence.
It's almost funny how simple it is when you hear it, the code that seems to govern the universe.
It is. You just start with 0 and 1, and then you add the last two numbers together to get the next one.
So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. Then 8, 13, 21. And on and on. But these aren't just numbers in a math textbook. You have to see them as, biological commands. They're telling a system how to arrange itself for maximum benefit with minimum waste.
And the person who really brought this to the Western world was Leonardo Casano-Bigolo. We know him as Fibonacci.
Right, around the late 12th, early 13th century, though, and this is important, he didn't discover it.
No, he didn't.
Ancient Indian mathematicians knew about these numbers centuries before. They called them the Virahanka numbers.
But Fibonacci was the bridge. He did something huge. He introduced the Hindu-Arabic numeral system, the 0 through 9 we use every day, to Europe in his book, Liber Abaci.
And that book, published in 1202, is where he posed this little thought experiment about rabbits breeding.
The famous rabbit problem.
And the solution to how many pairs of rabbits you'd have month by month that gave us the pattern. 1, 1, 2, 3, 5, 8.
The real magic, though, isn't in the numbers themselves, but in the relationship between them, the ratio.
Exactly. If you take any number in that sequence and divide it by the one right before it, say 34 divided by 21 or 55 by 34, the answer gets closer and closer to one specific irrational number.
That number is FEC, the golden ratio, roughly 1.618.
So why is that number so special? Why does nature care about 1.618?
That's the question, isn't it? It seems so arbitrary.
It's because it represents the most efficient state of packing. That's the key term, packing efficiency. If you need to fit as many things as possible into a space, like seeds in a flower, this ratio is the perfect answer.
Let's go back to that sunflower you mentioned. If you actually look at the seeds in the center, they're not in concentric circles, they're in spirals.
2 sets of spirals interlocking. And if you count them, and you really can do this, the number of spirals going clockwise and the number going counterclockwise will always be 2 adjacent Fibonacci numbers.
So you might find 34 spirals one way and 55 the other, or on a really big one, maybe 89 and 144.
And this isn't for looks. It's pure engineering. It makes sure every seed is packed as tightly as possible, but also that every single one gets the maximum amount of sunlight. Nothing is wasted.
You see it everywhere in plants once you start looking.
Yeah.
The scales on a pine cone, they often have 8 and 13 spirals. A pineapple, same thing.
It even dictates how leaves grow on a stem. To make sure no leaf is directly shading the one below it, the plant grows them at a specific angle.
The golden angle.
Which is about 137.5 degrees. It's derived directly from the golden ratio, and it's the most efficient angle possible for distributing things around a central point. It's perfect.
Okay, so if we take these numbers, this ratio, and draw it, what do we get?
You get the golden spiral. It's also called a logarithmic spiral. And its defining feature is something called self-similarity.
Meaning it looks the same no matter how big or small it gets.
Precisely. It can grow forever, outward or inward, and its proportions never change. It's the geometry of perfect, continuous growth.
And this is where things start to feel, well, a little eerie. It's where it stops being just about biology and starts looking like a fundamental law of physics.
Right. Let's scale up. Think of a nautilus shell.
The classic example.
As the creature inside grows, it builds a new, larger chamber. But the whole shell maintains that perfect logarithmic spiral. It has to keep its center of gravity and buoyancy stable as it gets bigger.
So that's one organism. But what about a whole planet's weather system?
Now you're getting it. Look at satellite images of a hurricane, the way the arms curl around the eye, the flow of trillions of tons of air and water.
It's the golden spiral.
It's the path of least resistance. It's the most energetically efficient way for that massive system to move. The same pattern in a tiny shell in a monster storm.
And it doesn't stop there. We look out into space with telescopes like the James Webb, and we see it again.
The arms of spiral galaxies, including our own Milky Way, they swing out from the center following that same ratio. We're talking about billions of stars, gas, dust, all held together by gravity on a scale that's almost impossible to get your head around.
And it's following the same geometric rule as the seeds in a sunflower.
The forces that govern galaxies are using the same math as a growing plant. That's a staggering thought.
It connects to that old idea, doesn't it?
Yeah.
As above, so below.
It's the perfect expression of it. The scale is irrelevant to the equation. The rules that built the universe are the same rules that built us.
Leonardo da Vinci definitely knew this. His Vitruvian Man is all about showing how the golden ratio is written into the proportions of the human body.
From the ratio of your height to the height of your navel, all the way down to the bones in your fingers.
The phalanges, right? The length of each section of your finger relates to the next one by the Fibonacci sequence.
It's literally right there in your hand. But the really mind-bending part is when you go smaller, much smaller, to the molecular level.
The blueprint of life itself.
The DNA double helix. The structure that encodes everything you are, if you measure one complete twist of that helix.
It's 34 angstroms long and 21 angstroms wide.
34 and 21. Two adjacent numbers in the sequence. An angstrom is an unbelievably tiny unit of measurement, but the numbers are right there. The code for life uses the universe's primary code for growth.
That's not just a coincidence. That feels like a signature.
It implies that the organizing principle of the cosmos is embedded in our very genes, and the connection gets even deeper when you look at how the universe itself is structured.
You're talking about the simulations, like the Millennium simulation.
Yes. They mapped the large-scale structure of the universe, and what they found is something called the cosmic web, this vast interconnected network of galaxies and dark matter.
And the astonishing thing, the truly unbelievable discovery,
was that the structure of that cosmic web, its nodes and filaments, is statistically identical to the structure of the neuronal network inside the human brain.
Let that sink in for a second. The way the entire universe is put together on the largest scale we can imagine is the same as the way the cells in your brain connect to create thought.
It just reframes everything. We aren't just, random bits of matter. We are a part of this magnificent, ordered, mathematical piece of art.
We are the flower.
And we are the storm, and we are the galaxy, just on a different scale, but playing by the exact same rules.
So understanding this, it's not really about math. It's about understanding our place in everything. Realizing that under all the chaos we see every day, there is this beautiful, invisible order holding it all together.
A thread, an unseen mathematical thread that connects your fingertips to the petals of a flower and stretches all the way to the edge of the cosmos.
So the next time you look at a flower or you just find yourself staring up at the stars on a clear night, remember that you're looking into a mirror reflecting the most fundamental truth of who and what you are.
For today, we take our leave. We will see you next time with the next discovery.